Okay, apply calculus to solve problems involving related rates. What are related rates? We'll work through this example so that we've got an idea of what's going to come up. So, a tap allows 2 litres per minute to pour into and fill, eventually, an empty cone. Okay, as you can see here, obviously. So we've got radius 10 centimetre, total height 30 centimetre, so water's pouring in at a nice constant 2 litres per minute. Fine. How quickly is the water level rising when the cone is exactly half full? And by half full I mean halfway up the height. Okay, so we've got 30 by 10. We want this thing to be specifically what the point we're interested in. H is going to equal 15 in centimetre. Okay, so a good thought at this point might be, alright, well, if that's 15, how wide is the radius? And what you might notice is that this triangle, bang, 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 is going to be similar to that triangle there. And so if they're similar, all your ratios are going to be the same. Well, this is 1/3 of that, so this will be 1/3, that's 5 centimetres. Beautiful. Okay, well, I need to know how quickly the water is rising at this time. Okay, well, what is that talking about? How quickly does the water rise? That's talking about how does the change in height happen as we have a change in time. So that's what we're interested in. Okie dokie. Well, we've established some stuff that we know. Do we know anything else about this scenario? Well, we do know how to get volume, or hopefully we know, how to get the volume of R squared H of a cone. Okay, so we've got that. Brilliant. So we can get the entire volume or the volume at any particular height, any particular radius or height. We know how these two are related at any particular time. We know that H is 3 times R. Beautiful. Okay, and we also know this bit, 2 litres per minute. Okay, so what's that? It's a rate of change. It's the change in volume with respect to time. Cool, which is 2, but I'm going to make this 2000 for the following reason. Hopefully we know that 1 centimetre cubed is equal to 1 millilitre. So since I've already got this in centimetres, rather than changing this to 0.05, it starts to get a bit clunky. Rather than having 2, I'll make this 2000, so I've got all nice positive integers. Cool, okay, so all my units are now going to be in millilitres and centimetres and minutes. Cool. Okay, I've got 3 different variables, that's, 3 different unit types, so that's usually a pretty good indicator that you're on the right track for related rates. Well, what do we have? We have dV dt. What do we actually want? We want dH dt. Is there any way of relating these two? So, let's go dV dt, and I need some expression where I get dH dt. Alright, well, if I notice, well, dt's the same, so what do I need to do? Actually, I should have put this here. No, it's okay, it doesn't matter. Cool. What I need is a dv on top and a dh to cancel out this one on the bottom. Cool. So, I've got dv dt. Yep, I've got dv dt, that's 2000. Okay, so 2000 equals dv dh, so the change in volume with the respect to the change in height. Do I have that? Well, we'll leave that out for now, I don't have that directly. dH dt, well, that's what I want to find, so obviously I'm not going to be able to just look up that. But if I have this, if I can find this, then I'll be able to generate this. So what we're after at this point is dv dt, dv dh times, and this will be our answer, dH dt. Okay, so we really need this guy. dv dh. Alright. dV dH. Well, that's just the expression for volume derived with respect to H. Do I have an expression for volume? Yeah, I do. But we've got this extra variable in here that we don't want, R. Well, conveniently, we can switch this around. So, I'll get rid of that for now. Alright, okay, the volume is 1/3 pi. We don't want R, So rearrange this, h on 3. So what have we got? R squared, which is now h on 3 squared, multiply h. So now I've got an expression of v in terms of just h, which makes it easier to get dv dh. Neaten this up a little bit. What do we get on 20? Actually, I'll make this even easier and leave it all 3 to the 3. And h was, sorry, no, we're just leaving it as h, so that's h cubed times pi. All good, yes, pi, yes, yes, yep, beautiful. Cool, okay, well, what's dv dh? Okay, well, this is all just nice basic stuff, so what do we get? Add another 3 onto the thing, so we'll have 3 squared on the bottom now, h squared. Cool, okay, well, I've got this. Now, you could change this into a 27 and change this into a 9 if you want, there's nothing wrong with that. I'm just going to leave it there because things are going to cancel out later. Okie dokie. So now we can say this thing is still 2000 dV dh, this guy, h squared on 3 squared by pi, multiply the thing we actually care about. Cool, alright. So I want this thing, so I need to divide by this guy. So I've got 3 squared multiply 2000 over h squared pi equals dh dt. So that's my nice general expression for dh dt. Cool. Well, specifically we were interested when h was 15. Notice that we've done everything nicely in general terms. We've not gone specifically for this point because, as always, there's typically part A, B, C, D. So we don't want to put in these defined positions if we can avoid it. But now that we've done a general solution, we can go a specific part of it. Cool, 3 squared by 2, that's a 2000, over h squared, so 15 squared, times pi equals what we're after. H equals 15. Cool, okay. Notice that we're going to have a 3 squared in this, so that's actually going to end up being 5 squared. That's a squared. Cool, 2000 divided by 25, 25 goes in 4, 4 goes 80, so we get 80 on pi equals dh dt when h is 15. Cool, so that's all our math part. Last little thing, we should always think about the units for this sort of stuff. So, just as a little aside, dh dt, okay, h was in centimetres, so this is in centimetres per, dt was in minutes, centimetres per minute. Now, most of the math will work out just fine. This can sometimes throw you out because it might say, oh, what's dh dt at h equals 15 centimetres, but it wants the answer in centimetres per second or some other variable change. So always write your units and then just check that everything marries up. In this case, it just said how quickly, so we're free to choose whichever units we want. Cool. Now, these can go nice and quick and easy like this one, but sometimes they can really throw you for a loop. So things that you should probably think about. First thing, always, always, always draw some picture of what's going on. It helps a lot. Conveniently, I gave that to you in this case. ID your variables. So in this case, we had height and radius are changing, and we also had volume changing, which was down there. And time was our other thing that was evolving, or changing. Beautiful, so ID whatever variables are potentially happening. Cool. Write down any relationship you've got. So in our case, there was a whole bunch. We had the volume of this thing mattered. Cool. We also found out that H and R are definitely going to be related. And what else did we need? Oh, and then the last thing was, okay, how does the derivatives of these relate to each other? And write a differential equation of some sort that includes what you're after. So ideally you're going to be able to find either one thing that you know and the thing that you don't know, and then figure out what's the third element in there. So with us, we had this first bit, we wanted this last bit, and so that tells us what the piece we still need is. Something to keep in mind is that sometimes you'll be able to write something like, well, just to pick, dv equals dh dr, just, it doesn't have to be the same variables, but it may be. Cool. You may write that same equation and you might know this, but it turns out the other equation that you've got is t in terms of r, in which case this would give you dt dr. Okay, well that's not the end of the world, because if you've got this, you can convert that to dr dt just by inverting whatever that derivative was. Beyond that, that's about the only thing. So always, always, always draw a picture, make sure you understand what's going on. Identify all the variables that are involved. Very commonly, you'll drop down to just 4 variables. So for us over here, we had volume, time, height, and radius. Very commonly you'll drop down to 3. Any extra ones are typically expressible in some relation between the other 3. Sometimes you have to go through a bit of tedium with that, but pretty well always you can reduce it down to 3 variables, and once you've got there, it's just a matter of getting a chain rule expression that allows you to link up 3 kinds of derivative. You'll know one, or you'll be able to generate one at least. You'll want one of them, and the other one that's missing, you just have to find a way to calculate. Cool. This is not terribly difficult when you do it correctly, but you can get lost down a rabbit hole pretty quickly. So do email me if you get stuck. I will probably try not to just give away how to do it. I'll probably just try to give you hints, because a little starting point goes a long way with these, because the actual math in this, not that complicated. Cool. Best of luck to you. Have a good day.